Hi, my name is Bahadur Akhmedov. Welcome to the course of Probability and Statistics. From this lecture, we're going to start learning about the properties of the probabilities and its axioms. So there are three important axioms of the probability, which is coming from its definition. So if you remember, we define the probability that some event A is going to happen as a ratio as a proportion of this A inside the whole sample space, right? So we said, hey, there exists some sample space, which is going to be denoted as a capital omega, which is going to contain all outputs of our experiments. Then this event A is going to be some part of this. So this A is inside the sample space. So A is subset of the sample space. And we are going to define the probability as a proportion of the size of the A into the size of the omega. So, and mathematically we are going to do this by just counting the number of items in A divided to number of items in the omega. For example, you might be given a problem with the box with lots of balls inside. For example, you've got 3 balls inside, 3 pink balls inside, and 2 white balls. So this is going to be omega, which is going to contain all items. And now you would like to find out probability of choosing a pink ball. It means that you are basically you're basically choosing some part of this omega, so this pink balls. So if I would like to find out the probability of choosing the pink ball, what we have to do is we just need to count the number of the items inside the subset, right? It's going to be 3, and divide this to the number of the items in total inside this omega. So there are 5. So it's going to be 0.6. So this is the definition of the probability, and from this definition it is clear that number of the items inside this A can't be bigger than number of the items inside this omega. So numerator is always smaller or equal to the denominator, so that is why this number is always less or equal to the 1. So at the same time, since we're dividing the sizes, right, so always we count the number of the items, those numbers cannot be negative, right? So that is why it is always going to be bigger or equal to the 0. So this is the first axiom of the probability, and there are 2 cases when the probability is equal to the 1 and the probability is equal to the 0. They basically mean that either the event is going to certainly happen, either the event doesn't happen at all, respectively. So for example, if the probability is equal of some event A is equal to the 1, it means that this event certainly happens. For example, you've got another box with the balls, and there are 3 pink balls inside of this box. And if I say, hey, what's the probability of choosing a pink ball from this box? You would say, hey, this is equal to the 1. So this is going to happen certainly, for sure, right? And another case when the probability of the event A is equal to the 0. It means that this never happens. Never happens. So it means that, for example, for the same example, if I say, hey, what's the probability of choosing a ball which is going to be white, you would say me, hey, this is equal to the 0 because there's no white balls there. So this is important axiom of the probability, and this should be really helpful for you when you solve the problems. So you need to always remember the definition of the probability, and if you have the solution of the probability when you get the number which is bigger than 1, or smaller than 0, then the probability that you have a mistake there is equal to the 1. So the second important axiom of the probability is about the complements of the events. So we first of all need to define the complement. So let A is an event So if you have seen before, so this is the part of the, this is a part of the omega. So we are going to define the complement of the A. So A prime is, so let me write its pronunciation. We're going to pronounce this as A prime. A prime is a complement of A. So this is another set. This is another set which is going to contain all the events from the omega which are not included to A, which is contains all the events from omega which are not included to the A. So let me give you an example. So the complement of the A, it's like all the events from the omega which are not included to the A. So again, I would like to give you an example. Was the balls. So there are 3 types of the balls, for example, 2 white balls, 3 yellow balls, and 3 pink balls. So if I would like to define the event A, it's going to be pink balls, right? So I would like to define this as a set. So this is going to be 1 pink ball, 2nd pink ball, and the 3rd pink ball. And if I would like to find the probability of the A, what I have to do is I just need to count the number of the pink balls and divide this to the number of the balls in the sample space in total. So this is our sample space. So there are 3 pink balls divided to the, in total I've got 8 balls, right? So probability of choosing a pink ball is equal to the 3/8. Now A prime, which is the complement of this set, A prime, which is going to be the complement, is going to contain all other balls from the omega which are not included as A. So they are going to be 2 white balls and also 3 yellow balls. So this is the complement, which is, yeah, so graphically not so difficult, right? And now let's find the probability of A prime. So the probability of A prime is going to be, we just need to count the number of the items here. So there are 5 items, and we have to divide this to the number of the items in the omega, which is equal to the 8. So this is the probability of the A prime, the complement of the A prime. So, and you can see from here one property, right? So, and the property tells you that if you sum the probability of the A and the probability of the A prime, it is going to give you 1. And this is the second axiom of the probability. So which basically tells you, hey, if you find the probability of the A and add the probability of the A prime to this, it is equal to the 1. And later on we are going to use this property lots of times, and from the perspective that if you know the probability of the A, for example, you can find the probability of the A prime by just subtracting the probability of the A from the 1 and vice versa. For example, if you would like to find the probability of the A but you know the probability of the A prime, you can find this by just subtracting the probability of the A prime from the 1. So these are the 2 important axioms which you have to know and which are superbly useful when we are solving the problems.